Okay, I think my slides are visible at your end also. Okay, am I right, Madan? Whether my slides are visible at your end, Madan Patil, please reply.
Yes, sir. Yes, sir.
Okay, so today we are going to start a thermal energy based processes. Okay, that is our unit number 5. Actually, our unit number 3, that is electrical energy, and unit number 5, this thermal energy. Actually, these are the combination. Okay, so whatever the processes belongs to this chapter number 3 and chapter number 5. So these are the one group. Okay, and that group is called thermoelectric energy based processes or electrothermal energy based, because here initially we are using electric energy, and at the that during the material removal process we are using that converted the electric energy is converted to the some form of heat or the thermal type energy. Okay, so that is this we can call it as a thermoelectric group. Okay, so today we are going to start the laser beam machining. Okay, that is in short LBM. Okay, in many times this process is called as laser beam cutting. Okay, laser beam cutting, because this laser normally it is used mainly used for the cutting operation. Okay, so but as per our syllabus the name is laser beam machining. So let us discuss this topic today. Okay, so as we all are familiar with the one important experiment which we have done during our childhood. Okay, so during our childhood we were doing the one experiment. What is that? That sun rays or the sunlight were focusing into the small area of the piece of our paper by using the lens. Okay, that you already remember knows that. Okay, so we were taking one lens. Okay, and we are focusing that sunlight through that lens on the piece of paper, or that small area of piece of paper. Okay, so when this sunlight or the sun rays is focused on that very small piece of paper by using the lens, then energy density of 1 watt power, okay, per mm square is generated. Okay, when I repeat, when this sunlight is focused on a very small piece of that paper by using the lens, then that time energy density, energy density of 1 watt power mm square is generated. Okay, so this energy is sufficient enough to burn that piece of paper. Okay, and we were calling it as a miracle or magic. Okay, but actually this is science. Okay, so similarly huge amount of energy can be generated. I repeat, similarly huge amount of energy can be generated in a lens, sorry, in a laser also, by focusing this laser light into the very small area, so that we can get a high energy density. Okay, and we can do the different kind of operations. Okay, like cutting, drilling, machining, micro machining, tripping. So different kinds of operations we can do, and more as this whatever the laser light is there, no, if you it's concentrated into the small area, very small area. Okay, or the very small can be made by this lending machine. Okay, the concept of that focusing the sunlight through the lens on the small area of the that small piece of paper, and generating the that heat energy or the energy. So same concept we have used for the our machining purposes. Okay, and so using the laser, focusing that laser through the small area on the some small portion of the workpiece, and removing the material. Okay, with the help of that thermal energy or with the help of that laser energy. So it is called the laser beam machining process. Got it? I repeat, huge amount of energy can be generated in laser, okay, by focusing this laser light into the very small area so that you can get a high energy density. Okay, that means the here we get the thermal energy, and we can do different kinds of operations like cutting, drilling, machining, micro machining, tripping. So these various kinds of operations we can do. Okay, but here we have to concentrate that laser light into the very small area, very small area. Okay, and through that, by concentrating, you can go for the small holes can be manufactured, okay, using this, or we can make small holes by using this laser beam machining. Okay, so hole diameter or the hole aspect ratio, okay, with the hole diameter, aspect ratio means what? Hole with the hole diameter less than 1 mm can be produced by using this laser machining beam. Okay, so normally this laser beam machining, it is mainly used for the drilling purposes or the cutting purposes. Okay, so whatever the aspect ratio is, the aspect ratio means what? Hole diameter should be less than that one, whatever that ratio is there. No, so if you want to go for the hole diameter less than 1 mm, so that can be performed using this laser beam machining. So first of all, we shall discuss the working principle of this laser beam machining. Okay, how these lasers are generated. Okay, most important in this laser beam machining process is that how these lasers are generated. Okay, so after that, we will discuss different kinds of laser also. That means the solid state laser, gas lasers. Okay, and then after that, we shall discuss the process characteristics of this laser machining uh, process, and at the end, we will discuss the different applications of this laser beam machining process. Okay, so this is the outline about this our topic, laser beam machining. Okay, so very first, we shall start with the working principle of this laser and how this laser is generated. Okay, so you can see in this slide also. Okay, so this is the first slide about that. So as we know that uh, that uh, that Einstein hypothesis, okay, hypothesis of Einstein, that is one concept. Okay, actually, whatever now I am explaining, no, that is a concept which we have learned in our engineering physics or in the 11th or 12th standard physics. Okay, so firstly, I am going to explain that how this laser is generated. Okay, or production of the laser. Correct. So we are familiar with the word concept, that is hypothesis of Einstein. So that Einstein hypothesized that under appropriate condition, light energy of a particular frequency can be used to stimulate the electrons, okay, in an atom for our purpose to emit additional light with exactly some characteristics as that of whatever the original stimulating light source is used. Okay, so you can consider this figure here. Okay, so and here you can see first figure also, this one. Okay, I repeat that hypothesis of Einstein, that Einstein hypothesized that under appropriate condition, light energy of particular frequency can be used to stimulate the electrons in an atom to emit additional light with exactly same characteristics as that of the original stimulating light source. Okay, so we'll explain this with the help of this diagram. So here you can see an atom is there. Okay, so when in this figure, So when this atom is in the Q energy level, okay, in the Q energy level, you can see here that this line, Q energy level, okay, when our atom will be in the Q energy level and light of photon is falling on this atom. So this atom actually, that is photon, is absorbed by that your atom. Okay, this is your energy level, that is Q energy level. Okay, and the light of photon is falling on this Q. You can see here, I have shown that. Okay, and that photon is falling, that light of the photon is falling on that energy level, that is on the this atom. Okay, so actually this photon is absorbed by that atom, correct? तुम्ही बघू शकता इथं दिसतंय सगळ्यांना हे photon कुणा fall झाले तर त्या atom वर. Now this atom comes to the higher level, okay, by absorbing that photon, whatever the atoms at Q level, energy level, no, so that will come to the higher level at P, that is this higher level P. Okay, so this atom cannot stay at that at this energy level for a long time, so it will decay by sorry, it will come back to the lower energy level. Okay, once again it will come to the their original level, that is a Q level. You can see arrow also. By absorbing, you can see actually through this my mobile I'm not able to highlight. Okay, please consider highlighting happening. Okay, so at start that atom at the energy level Q, it will absorb the energy from the photon, then it will go to the, it will come to the higher level, that is P energy level. Okay, but it will not stay for the large time at that higher level. It will immediately come to the their energy level Q. Okay, so while it is coming back to its lower energy level, no, so it will emit a proton. Okay, so emission of that proton it will happen. So you can see that zigzag arrows. Okay, that means the emission of that proton. So there are two types of emissions normally are there. Okay, there are two types of emissions are there. One is the stimulated emission and another one is called the spontaneous emission. Okay, I repeat, while emission of that proton, there are two types of emission. One is called stimulated emission and the second is called spontaneous emission. Now that stimulated emission is there, so this emission actually does not depend on that stimulated light. Okay, stimulated emission is there, so this emission actually does not depend on the stimulated light. It is independent of the that stimulated emission. It is depend on that stimulating light source. Okay, so heat source whatever is there, no, there on that only it will depend. Okay, I repeat, it is independent of the one minute. It is independent of the that whatever the stimulated emission. So it is normally it is called the stimulated emission. Okay, and the second emission, that is spontaneous emission. It is independent. First one, that stimulated emission, it is depend on the stimulating light source or heat source, and that spontaneous emission is there, no, it is independent of the stimulating light or the heat source. So it is called spontaneous emission. So there are the two operations are going on. One is the absorption of the photon by an atom. Okay, it comes to the higher energy level. Okay, and then it comes to the, or it decays back to its lower energy level. Okay, that is a Q. Okay, and while it is coming from the higher level to the lower level energy, it emits the proton. Okay, so this emission is either spontaneous energy emission or the stimulated emission. So just as I have mentioned, two types of emissions are there. So now consider second figure. Consider this second figure. Okay, this was the first. Okay, now second, consider now here, consider atom in this second figure. Whatever that spot is there, no, that is the atom. Okay, now if that atom is brought to the energy level 3, that is E3, by an outside energy source like heat or the light. Okay, so our atom I have shown in the energy level 3. Okay, so you can brought that atom to the your that level E3 by an outside energy source like light or the heat. So this atom is allowed to decay back to the that ground state. Okay, one minute, please, 1 minute. Huh. So so by outside energy source like light or the heat, you can brought that atom to the energy level 3, E3. So this atom then is allowed to decay back. Decay back means of breakdown back to the ground state level state at the E0. Okay, you can see that arrow also. Okay, it is pointing towards the it's a ground level, that is E0. So as a result, photon is released. Okay, okay. While coming back to the it's a E0 level, from that atom, that photon will be released, and this photon contacts with the other atom in that lasing medium. So this atom will also break down back and release a photon having the same characteristic, means the same characteristic means what, same wavelength. Okay, same phase and the same direction and the same energy. So it will also generate another photon having the same characteristic. Okay, like same wavelength, same phase, same direction, same energy. So this chain of the reaction actually continuously happening, and stimulated emissions of the photon will take place. Okay, so this sequence of triggering of clone that photon, no, from stimulated atoms or the molecules, it is called the stimulated emission. Okay, it is called stimulated emission. I once again repeat. Okay, I am explaining about the stimulated emission of that photon. No, so whatever your atom is there, no, at state number E3. Okay, so that atom we can take back to the, or break down into back to the your E0 by releasing photon. Okay, and this proton will contact with other atom in that lasing medium. What is the lasing medium is there, no? So in that medium, that atom will contact with the that photon will contact with the other atom. So this atom will also again break down back and release once again photon, again having the same characteristic, means the same wavelength, same phase, same direction, and the same energy. So it will also generate another atom. Okay, sorry, it will generate another proton having the same characteristic. So this chain of the reaction actually continues and stimulated emission of the proton takes place. Okay, so this sequence of triggering of the proton from the stimulated atoms or the molecule is called stimulated emission. Okay, so energy source is as usually, as we know that it is so powerful. Okay, that is required to be so powerful. Okay, so most of the elements, most of the atoms in that lasing medium, no, that should be higher level energy. Okay, that atom should be higher energy level, and it will release that proton and release the number of protons, and that action of the reaction keeps on going. Okay, so this is actually called the physics concept, that is population inversion. It is actually population inversion, and it refers to the population of atoms or the molecules in the lasing medium. Okay, got it? Whatever I am explaining, that is already you learn in the your physics, but as we are going for the laser beam machining, no, so we should know how the laser is generated. So now we got the concept of the stimulated emission. Okay, so now for this stimulated emission of this protons, or we can call laser, there are two conditions. Okay, there are two conditions. Okay, I repeat, for this stimulated emission of these protons or laser, there are two conditions which has to be fulfilled. Okay, so for a working laser, there are two conditions which has to be fulfilled. So first one condition is that energy source provided, whatever the energy source providing the initial stimulation. Okay, what are the energy sources is there, no, which are provided for the initial stimulation, no? So that should be powerful enough, so that majority of atom and the molecule which are present in the that lasing medium, no, that should be in that higher energy state. And if majority of atoms are not in that higher energy state, so it will not generate the protons. And while it is coming, that proton generation, it is happening while it is coming or digging back to it's that lower level. So if that atoms will not be at that powerful level, no, then it will not generate photon. Okay, so first condition is that energy source which providing the initial stimulation, no, should be powerful enough, so that majority of atoms or the molecules attain that higher energy level. Okay, and then only while coming back or while digging back to the lower level, it will generate photons, or it will release the photon. So most of the atom in the lasing medium should be at the higher energy level. So you need an external source like heat or the light, so that most of atoms can be in the that lasing medium, means what, in the higher energy level. Okay, so you need the external source like heat or the light. Okay, for our purpose, for your atom should be in the higher energy level. Okay, and then only if your atom will be at higher level, no, then while coming or while breaking down to the ground level or the lower energy level, no, then only the photon or the laser stimulated emission will happen. Okay, now the second condition is that to provide the working laser, it needs a feedback mechanism. Okay, to provide or to produce working laser, Okay, whatever the we are producing the laser now, that to produce that working laser, it needs a feedback mechanism. So this feedback mechanism, that I am going to explain this feedback mechanism in the next, or in the next slide. Okay, so remember this condition also. Okay, to produce the laser, it requires feedback mechanism. Okay, so now, okay, before going for a further slide, I need some feedback from the student side, whether whatever I am explaining the physics, whether it is refreshing your knowledge. जे तुम्ही शिकलाय आधी ते तुमचं रिफ्रेश रिफ्रेश व्हायला लागलंय का नाही फिजिक्स मध्ये शिकलेला. कोणीतरी बाबा सांग जावा, येस नो. Because whatever I am explaining now how to produce that laser, this part, when I was teaching this subject in the last year, no, for the final, that time I will not explain, because already final students already know, aware about this point. Okay, but you are in third year, so I assume that you should know, or I should explain you. So that purpose I have taken this. समजतंय का बाबांनो की बाबा लेझर कसं प्रोड्यूस होत आहे, त्या ॲटम हीट एनर्जी, सॉरी हीट किंवा लाईट जे आहे ती कसं इमिट, त्या प्रोटॉन कसं तयार होतात, आणि त्याला त्या प्रोटॉन जे इमिट झालेत ते दोन प्रकारे असतात, एक स्टिम्युलेटेड इमिशन आणि एक दुसरं असतं ते स्पॉन्टेनियस इमिशन. आणि ते स्टिम्युलेटेड जे इमिशन असतं त्याला आपण लेझर म्हणतो ना, कारण की लेझरचा अर्थ काय, शॉर्ट फॉर्म, लेझरचा शॉर्ट फॉर्म का, सॉरी शॉर्ट फॉर्म नाही, लॉंग फॉर्म. ओके, लाईट एम्प्लिफिकेशन बाय स्टिम्युलेटेड इमिशन ऑफ द रेडिएशन, करेक्ट, त्याला लेझर म्हणतो ना आपण. आणि ते लॉंग फॉर्म. पण लेझर म्हणजे काय, इज द लेझर आपण म्हणतो ना, त्याला म्हणतो की डिव्हाइस दॅट इमिट द लाईट थ्रू द प्रोसेस ऑफ दॅट ऑप्टिकल amplification based on that your stimulated laser or stimulated emission. ओके, थोडंसं समजतंय ना की लेझर कसं प्रोड्यूस व्हायला लागलंय, समजतंय का? येस नो तर म्हणा चॅट बॉक्स मध्ये, येस नो तर म्हणा बाबा, समजतंय नाही समजतंय. मी अजून त्या वर्किंग प्रिन्सिपलकडे गेलोच नाही, मी तुम्हाला म्हणजे मागची थिअरी सांगतोय अजून की लेझर कसं प्रोड्यूस होतंय, नॉर्मली काय फिजिक्स आहे मागचा. ओनली दॅट रोल नंबर 5 सेड येस, other remaining 32 students, are you in this class or not? Okay, yes Pranay, I am going to explain that spontaneous emission also, don't worry. Okay, 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 now you got the idea about the how that stimulated emissions are producing. Okay, from the your atom which are present at the higher energy level, and by coming back to or digging back to the its lower level energy level, how that protons are releasing of the emission is the proton, and that is laser. Okay, and that whatever the producing that working laser, no, you should fulfill the two conditions. Okay, that means your whatever the atoms which are at higher level, no, it should have the enough energy. Yeah, okay, so for that purpose we should have the external source like heat or the your light. Okay, and there should be have the feedback mechanism while producing the laser. So these are the two conditions. Now see at this figure, now you can see here in this figure, this is a laser beam. Okay, I have shown that beam, red color, no, that is a laser beam. So a series of photons are coming from that lasing medium. Okay, this is called the lasing medium. Okay, from higher energy level to the lower energy level. Okay, so that time series of protons are coming. So these protons are generated there. So these protons which are that what are the medium is there, no? So these protons are actually focused by using the one simple lens. So it is focused by using a simple lens. Okay. So for that purpose, you can see that curvature part. It is called the focusing lens. माझ्याकडे काय पहिल्यांदा जे atoms हायर लेवलला होते एनर्जी लेवलला ते खाली लोअर लेवलला येताना इमिशन होते फोटॉनचा. ते फोटॉन म्हणजे काय तर माझं लेझिंग मीडियम. ओके. मग ते जे बीम आहेत ते लेझर्स म्हणू शकतो आपण, लेझर. सो दॅट आय हॅव शोन बाय द red color. And to focus on the workpiece in the small area, we require focusing lens, and that focusing lens I have shown there. Okay, you can see this is a focusing lens. So while it is focusing, so it can concentrate. Okay, you can see it can concentrate into the very small diameter. It can be concentrate it can concentrate into the very small diameter. So it is less than 1 mm. So it can be concentrated into a very small diameter. So this amount of energy, whatever the amount of energy in that laser is there, no? So this amount of energy, that high energy density, can be achieved by using that this laser. Okay, high energy density. Okay, that can be achieved by using that laser. So this amount of energy can be used. Okay, आता माझ्याकडे काय हाय एनर्जी डेन्सिटी आहे त्या लेझरला. ओके, because we have achieved that high energy density by using that laser. Okay, red. So that amount of energy can be used for melting and for localize the, I'm saying localize the melting, because we are concentrating on the small area. So when we should call it as the that localized melting and vaporization of the material. आता समजलं, जे लेझरची हाय एनर्जी डेन्सिटी आहे ती एनर्जी मी कशासाठी वापरतो तर मेल्टिंग अँड वेपरायझेशन ऑफ द मटेरियल ऑफ दॅट वर्कपीस. ओके, सो हियर यू कॅन सी हियर assisting gas is used. Okay, assisting gas is used. Okay, that lines I have shown. So here assist, or you can call assisting gas is used. So this assisting gas actually helps to cool down that material. Okay, assisting gas or inner gas normally used. Okay, also it helps to eject the molten or the vaporized material from that machine the surface. Okay, whatever the machine surface is there, no? So to remove that molten or vaporized material or eject that molten or vaporized material, we can take help of that assisted gas. Okay, also that assisting gas, it helps to avoid this molten material to damage that lens also. Okay, it will help to avoid this molten material to damage the lens. Okay, so for that purpose we are using that assisting gas. Okay, so this is about the how we have produced that laser, that is stimulated emission from the atoms. Okay, and how we have used that stimulated emission, means the laser beam, to remove the material. So to remove the material, to focus that laser on the small area of your workpiece, we have used the focusing lens. Correct. And with the help of that energy density of the laser, we have removed a material from that workpiece, small workpiece, using two actions. One is the melting and the vaporization. Okay, again that melting will happen from that localized surface of the your workpiece. So localize the melting and vaporization of the workpiece or material your material removal will happen. Okay, and to eject or to remove that okay, remove what to take out, take out that molten or vaporized material from the machine surface, we need or we are taking the help of the assisting gas, and also that assisting gas, it helps to avoid the molten material to damage that lens. Okay, so this is the basic principle. Okay, so here first condition, whatever the first condition is there, no, to for our working laser. Okay, we require the high source, high energy density source. Okay, that condition is fulfilled. Now feedback mechanism. Now I will explain the feedback mechanism. Okay, as we know that to produce that laser, we require the feedback mechanism. So now I will explain the feedback mechanism. Okay. Now before a feedback mechanism, uh, one minute. एक मिनट में पानी पीते एक मिनट. Okay, so before that feedback mechanism, that whatever the question asked by the Pranayana, that I will explain that because as we need the that concept of laser, know how to produce. So for that purpose, we have concentrated on the simulated emission. But as we know that photons will be emitted with the two types of emission. One is the simulated emission that we have discussed. Now second is the spontaneous emission. Okay, which is independent on the heat source. So now I will explain how to produce that spontaneous emission. So when that whatever the when that atom or that laser ions which are is there, no, so that atom is excited from that into that higher level, no, that is that while exciting means what पुढच्या level जाताना by absorption of the proton. That time it may take time. Okay, that is spontaneously it may take some time, and that time whatever the atoms which came at the that top that higher level, no, so that atom spontaneously, okay, or spontaneously sorry spontaneously it will return to the its a ground state. Okay, uh, or to with the help of the some intermediate energy level also, means what, by step. So that time they are releasing the energy in the form of proton. Okay, in the form of proton, and while that coming back to the or by releasing that energy in the form of proton, so that will carry the some energy in the form of random. So that whatever the emission is there, no, that process in which whatever the quantum mechanical system is there, or such, or you can call it as the quantum is that molecule or that atom or the that subatoms or small particles are there, no, So that will transmit from the excited energy state, that means the higher to the lower, that is ground. At that time, it will emit quantified amount of energy in the form of proton. No? So that emission is called the spontaneous emission. Okay, quantified amount of energy is emitted. Okay, in the form of that proton. So which is depend on that source, independent on the source. So that is called the spontaneous emission. That means immediately जसं प्रोटॉनचं ऑब्सेप्शन झाल्यानंतर जसं तुमचा ॲटम वरच्या लेवल जाणार आहे तसं इमिजिएटली or spontaneously it will come or return back to your ground. No, that time whatever the emission is producing, no, or releasing of the proton, no? It is called the spontaneous emission. Okay. Okay. Once again, here I will tell that what are the that spontaneous emission is there, no? So that will take place without that interaction with the other protons. Okay, that means that as we know that one proton will come contact with the another atom, then it will release the another proton. Okay, so here during that emission of the spontaneous emission is there, no? So there is no interaction with the other protons, and that direction and the phase are whatever that direction is there, no, and the phase are that are random. But in case of the stimulated emission, okay, so that stimulated emission is there, no, that takes place when the excited whatever the electron or the atoms is there, no, so that will interact with the another proton. Okay, this is the main difference. Okay, जर दुसऱ्याशी इंटरॅक्शन होऊन अनादर प्रोटॉन जर जनरेट होत असेल, ओके, दॅट कंटिन्युअस सायकल, then that time we are calling the stimulated emission, and without contact, without interaction with the other emission, other proton, त्या टायमाला जे इमिशन होतं त्याला स्पॉन्टेनियस इमिशन म्हणायचं. ओके, कळलं आता आता थोडं. हॅलो प्रणय डिस्ले. हा, आता समजलं. ओके, बेसिक जसं मी मला एक्सप्लेन करत होतो की बाबा एक ॲटम वन सेकंड इन मराठी अजून ॲटम जर तुमचा लोअर लेवल आहे, लोअर एनर्जी लेवल आहे, तो काय करणार, प्रोटॉन ऍब्सॉर्ब करणार आहे. त्याचे प्रोटॉन ऍब्सॉर्ब केल्यामुळे काय होणार आहे, वरच्या लेवलला जातो ॲटम जाणार आहे, आणि तो वरच्या हायर लेवल एनर्जी लेवलला जास्त वेळ थांबणार नाही, तो इमिजिएटली खाली येणार आहे. ओके, इट विल रिटर्न बॅक टू दिस दॅट ग्राउंड लेवल. ओके, मग त्यात स्टेप बाय स्टेप म्हणजे E4 नंतर E3 2 आणि 0 ला येणार तसं. ओके, ते आपल्याला माहिती आहे फिजिक्स. असं खाली येत असताना ते प्रोटॉन काय होणार, रिलीज होते ना, आणि रिलीज झालेले प्रोटॉन जर दुसऱ्या प्रोटॉनशी कॉन्टॅक्ट मध्ये नाही आले, म्हणजे इंटरॅक्शनच नाही झालं, तर ह्या इमिशनला काय म्हणायचं, तर तुमचं इन्स्टंटेनियस इमिशन म्हणू शकतो आपण. ओके, सॉरी इन्स्टंटेनियस नाही, स्पॉन्टेनियस इमिशन. ओके, विदाउट इंटरॅक्शन विथ द अदर. पण आता रिलीज होत असताना प्रोटॉन, आता एक प्रोटॉन रिलीज झाल्यानंतर तो प्रोटॉन पुढच्या ॲटम मध्ये ऍब्सॉर्ब होणार, आणि त्याच्यामुळे अजून प्रोटॉन तयार होणार ना, इंटरॅक्शन होणार. ओके, so if your that emission taking place with the interaction with another proton, that time it is calling the stimulated emission. Okay, बरोबर आहे. मग आपण मला म्हणल्यानुसार की असं ही चेन किंवा ही जी सायकल आहे कंटिन्युअसली चालू होते. आय थिंक आय हॅव गिव्हन अप टू द मार्क सम दिस एक्सप्लेनेशन. हा, आता बेसिक डिफरन्स कळाला ना, जसं मी मला म्हणत होतो की दोन इमिशन आहेत. आता समजलं.
Yes sir, yes sir. Yes,
ओके,
sir.
बेसिक म्हणजे बऱ्यापैकी बेसिक आयडिया तुम्ही सांगितली बुवा ह्याचे. ओके, सो मे आय गो फॉर दॅट फीडबॅक मेकॅनिझम because this
Yes,
feedback
sir. You
mechanism
can.
is the hello, may I go, may I proceed for this feedback mechanism?
Yes, sir.
Okay, okay. Because this feedback mechanism is what? It is a one condition that has to be fulfilled during that production of the. ओके, विनायक गवळे तुम्ही आता येताय 11:15 वाजता, काय करायला पाहिजे तुमचं? पुन्हा म्हणणार की सर तुम्ही अलाउड केलं नव्हतं मला. विनायक गवळे अनम्यूट व्हा जरा, मला सांगा एवढा उशीर का? मागच्या वेळेस म्हणते सेमच बॉम्ब होते. लवकर जाओ विनायक, से यस ऑर नो. विनायक गवळे, विनायक गवळी बोला काय तर. लेक्चर तर चालू होऊन तास होऊन गेला, 1 तास. लवकर जाऊ.
सर
ओके
सर लाईटचा प्रॉब्लेम होता त्यामुळे.
बरं, ओके ओके ओके. आता काय लाईटचा प्रॉब्लेम सांगितल्यानंतर आम्ही काय सांगणार, बिकॉज सेम प्रॉब्लेम आहे. ओके ओके, लेट इट बी, नो प्रॉब्लेम. ओके, वी वर डिस्कसिंग अबाउट फीडबॅक मेकॅनिझम. ओके, फीडबॅक मेकॅनिझम म्हणजे काय? जसं आपल्याला माहिती आहे की टू बिल्ड दॅट वर्किंग लेझर नो, वी हॅव टू फुलफिल द टू कंडिशन. एक पहिली काय तर तुमचं ॲटम जे असणार आहे किंवा एनर्जी असणार आहे ते तुमचं हायर एनर्जी सोर्स पाहिजे. ओके, म्हणून ते आपण एक्सटर्नल हीट किंवा लाईट वापरणार आहे. ओके, सो दॅट कंडिशन विल फुलफिल. द सेकंड इज कंडिशन दॅट टू प्रोड्यूस दॅट लेझर it requires some feedback mechanism. So I will explain now feedback mechanism. Okay, so what is feedback mechanism? So feedback mechanism is what? You can see the diagram also. So photons actually generated during the laser in that lasing medium. So for machining or to take place that machining, actually we need a sufficient amount of proton, correct? For machining or to take place that machining, we need a sufficient amount of protons. Okay, that means a laser. So when there is a beam of laser, there is a beam of photon, beam of the photon, then beam of that beam means of that laser or that beam or the that passage, you can call passage of the energy is there, no, or beam of the energy is actually falling on the workpiece surface. Okay, actually it is falling on the workpiece surface. Then when it would fall on, then only that machine will take place. Okay, and you can use that laser for to carry out that machining, as we know that. And so to generate the more energy or to generate the more number of protons, there should be feedback mechanism. Okay, feedback mechanism ची काय गरज आहे तर मला पहिले कंडिशन म्हणजे बेसिक काय तर मला मशीनिंग ऑपरेशन करायचं आहे ना. मग ते मशीनिंग ऑपरेशन व्हायसाठी आपल्याला दॅट बीम ऑफ एनर्जी म्हणजे काय लेझर वी हॅव टू फॉल ऑन दॅट युअर वर्क सरफेस. आणि ते बीम कसं पाहिजे, बीम ऑफ द एनर्जी, तर त्याच्या सफिशियंट अमाऊंट ऑफ एनर्जी पाहिजे, म्हणजे सफिशियंट अमाऊंट ऑफ प्रोटॉन्स पाहिजेत. मग ते सफिशियंट अमाऊंट ऑफ प्रोटॉन म्हणजे काय तर मोर नंबर ऑफ प्रोटॉन. So to generate that more number of photons, we need or we require that feedback mechanism. Okay, so now come to the feedback. So you can see this is the feedback mechanism as I have shown the in this diagram also. So this feedback mechanism is that it captures and redirects the portion of the your coherent protons back into the active lasing medium. Okay, to stimulate the emission of the more protons so that same frequency and phase of this proton can be generated. I repeat, feedback mechanism is what? It captures and redirects a portion of protons. Okay, it captures and redirects the portion of the protons back into the active lasing medium. Okay, it captures proton and it will back to the into the active lasing medium. So for purpose to stimulate the emission of more protons, so that same frequency same phase of the proton can be generated. So whatever protons are coming outside from that lasing medium, it reflects back, it captures and redirects the proton into that lasing medium again. Okay, so that it stimulates the more atoms of that lasing medium. Okay, and so that emission of more and more protons can be generated. Some more protons of the same frequency and same phase can be generated using this feedback mechanism. So it basically this stimulates this feedback mechanism is what basically it stimulates the emission of the some more protons into that lasing medium. So as it emits more number of protons into this lasing medium, so large number of protons are available or it will generate, and that large number of protons you can use or you can avail for that machining. Okay, so it maintains that amplification process. Okay, amplification is what to go for more and more. Okay, amplification process. Okay, through that stimulated emission. Okay, and also it maintains the amplification process through that this stimulated emission. So it is designed. Okay, this your feedback mechanism. No, it is designed to allow the some percentage of this coherent proton to exit the system as a laser light, and which is used for the machining purpose. So what is the now time come to that basic question: what is the full form of our laser? Laser means what? Light amplification of stimulation. So sorry, stimulated emission of the radiation. Okay, light amplification of stimulated emission of the radiation. Okay, so you can see in this diagram, this is your whatever you I have shown now, this is your laser medium or sorry lasing medium is it. So they are feedback mechanism which is used this, you can see the curvature part. Okay, there is a here feedback mechanism. Here I have used mirrors. Okay, because we want more and more protons now. So here you can see feedback mechanism, that is mirror, which is used so this is used for the feedback mechanism. So this is a, now you can see we have the energy source. Okay, basic. Okay, कारण की लेझर तयार करायला तुम्हाला हीट पाहिजे की नाही किंवा एनर्जी. So for a purpose, electricity or that energy means the light source, heat source. Okay, it is used. Okay, and that heat source or light source or energy which is used to stimulate the atom in the lasing medium. इथं काय होणार ते स्टिम्युलेशन होणार. ओके, म्हणजे तुमचा ॲटम जे खालच्या लेवल असणार आहे तो वरच्या लेवलला जाणार म्हणजे हायर एनर्जी लेवलला. ओके, सो दॅट stimulation of the atom in that lasing medium will occur. Okay, so higher level. Okay, so because of this whatever the feedback I have provided now, that feedback mechanism will help that to to whatever the protons which are coming outside, so that protons will have to redirect into the lasing medium. Okay, so for that purpose mirror means the feedback mechanisms are used. So it can react with the to more protons. Okay, it will react with the more protons and it will generate emission. Okay, it will help to generate the more photons. So this feedback means the your mirror. So these are the feedback mechanism. It is nothing but just a so protons are actually reflected back from the mirrors and comes again into the lasing medium. So this so what are the laser is or not? That means the full form as I have explained. Light application of the simulated image of your radiation. Okay. So you can see in the this diagram also. Here also I have shown the mirror. Okay. Turning medium here also. Here turning medium. The mirror here also. Okay. काय फक्त मला amplification करायचं ना. Purpose to produce the laser. Okay, to do that amplification means what, to produce the more and more proton we require that mirror. So okay, काय होणार जे बाहेर चाललेत ना तुमच्या लेझिंग मीडियम मधनं जे प्रोटॉन ते पुन्हा अजून येणार तिथं. सो इट विल दॅट ड्यू टू दॅट युअर फीडबॅक मेकॅनिझम और ड्यू टू दॅट मिरर प्रोटॉन काय करणार जास्त जनरेट होऊन त्या लेझिंग मीडियम मध्येच येणार. ओके ओके. सो अप टिल नाव आय हॅव डिस्कस्ड that some basics. Now we'll discuss the working principle. So now what is that basic working principle of this laser beam machine? So as we know that energy input, that means in the form of heat or electricity or the light is given into this lasing medium. Okay, you can see also this is diagram that I'm going to so okay. So as we know that yeah, you can refer this diagram, no problem, or will have see this. So energy input in the form of heat energy electricity or the light. Okay, आता तुम्हाला काय असेल की ह्याला थर्मोइलेक्ट्रिक का म्हणतात किंवा इलेक्ट्रोथर्मो प्रोसेस का म्हणतात, कारण की तुम्ही इलेक्ट्रिसिटी वापरतोय आणि जे मटेरियल रिमूव्ह होतंय ते कशामुळे होते तर मेल्टिंग और दॅट हिटिंग और वेपरायझेशन मुळे मटेरियल रिमूव्ह होते. सो energy input which are in the form of heat, electricity or the light is given into this your lasing medium as a source of energy for our purpose to stimulate the atoms to the your higher energy level. Okay, so now this energy from this laser medium come outside as laser wave, which is useful for different activities, different machining activities like drilling, welding, cutting, soldering, heat treatment purpose, or the hardening of the workpiece material, and the many things. So electrodes are actually used at both the end of your tube. Okay, now you can see this diagram. So electrons are actually used at the both end of your tube. So you can see here, this is a laser beam. Okay, sorry, this is a gas laser. This is CO2 gas laser. Okay, so here you can see this is a cathode. Cathode दाखवलाय बघा मी. Okay, tube मध्ये काय झालंय cathode. So this is one tube which is filled up with the gas, maybe CO2 gas. CO2 gas आहे त्यात. ओके, त्या गॅस लेझर ट्यूब दिसतंय ना तिथं, आणि तिथं एका एंडला काय कॅथोड दाखवला आहे. ओके, सो यू कॅन फिल दॅट ट्यूब विथ द हेल्प ऑफ गॅस, मे बी CO2 गॅस, कार्बन मोनॉक्साइड or the helium gas or the nitrogen gas as a lasing gas, and it is filled up at a low pressure. So the two electrodes are actually used to energize that atoms. Okay, electrode दाखवलेत बघा तुम्ही, कॅथोड जे दिसतंय ते दोन electrodes and that are used at the both end of that your tube. Okay, then what are the we are giving the electric energy, you know, that electric current, it will stimulate, or in maybe other in that lasing medium, other lasing medium, it will stimulate that gas atom or molecule in that tube. सो आता काय करणार, ते लेझिंग मीडियम माझा गॅस आहे, ते काय होणार, स्टिम्युलेट होणार. कशामुळे, तर तुम्ही ते हे दिले ना, इलेक्ट्रिक करंट दिलेला आहे, त्यामुळे स्टिम्युलेट झाल्यामुळे आपल्याला काय होणार, प्रोटॉन्स तयार होणार ना. सो अगेन दॅट फीडबॅक मेकॅनिझम इज देअर. सो अगेन दॅट फीडबॅक मेकॅनिझम कन्सिस्ट ऑफ द पॅरल मिरर्स. यू कॅन सी ऑल्सो ट्यूबच्या प्रत्येक ठिकाणी पॅरल मिरर्स दाखवलेत बघा. टर्निंग मिरर तुम्ही बघू शकताय, आणि इकडं आउटपुट मीडियम. ओके, हे काय मी दाखवतो, तर CO2 लेझर जे आहे ना, त्याची मी डायग्राम दाखवतोय. ओके, तिथं आपल्याकडे काय असतात, 2 ट्यूब असणार आहेत, त्याच्यात तुमच्याकडे लेझर गॅस असतो. ओके, त्या लेझर ट्यूब मध्ये, आणि ते लेझर गॅसला तुम्हाला स्टिम्युलेट, दॅट लेझिंग मीडियमला स्टिम्युलेट करायचंय ना, त्या गॅसला स्टिम्युलेट करायचं, तर त्यासाठी इलेक्ट्रिकल एनर्जी दिलेली आहे. ओके, to go for more stimulation or that amplification, we have that mirror or that feedback mechanism, which are consist of the mirrors. Okay, at the end of the tube. Okay, at the both tube. So one mirror is fully reflective and another mirror is partially transparent. Okay, which gives the laser output. So here you can see this output mirror at the one end, and which is partially transparent. So through this partially transparent mirror, lasing, that protons actually comes outside as a laser medium, and as a laser protons come outside, but this mirror and this mirror they takes place actually highly reflective mirrors. So this highly reflective mirrors are used. So again at the other end we have the turning mirrors. So there are 2 pipes are also there. So when when the protons are actually coming outside from this pipe, no, then it will reflect here, and then again it will reflect here. Okay, you can see in this diagram also. So that reflection will happen to that in that mirror, and then it will come inside that first chamber. Okay, and then again it will transmit through that partially transparent mirror. But here we are using the highly reflecting mirror. Okay, when protons is coming outside from your highly reflecting mirror, no, because of highly reflecting mirror, so it will come inside that reflection. The after reflection it will come inside. Okay, from that highly reflecting mirror. So again that coming inside, no, that process. So here it redirects the proton to come back again into the lasing medium. Okay, because of that mirrors. So for this CO2 laser or for gas laser, this kind of folded, it is called this kind of folded resonator. Okay, folded resonator axial flow CO2 means what? This is used. Okay, this diagram is for of folded resonator axial flow CO2 laser. Okay, and this is for generating 100 watt of laser power. Okay, certain length of gas also is required. Okay, so when we need a huge power, no, then we should have the longer length for this pipe. Okay, longer length should be there for this pipe. So this longer means what, depend on your whatever amount of energy we are going to produce, no? So depend on that you should so sometime in the lab uh, we cannot go for the longer pipe. So small pipes can be you can keep uh, in that your lab, and you can use more pipe also. Okay, so small pipes we can keep. So from every pipe, so this kind of, you can see the turning mirrors can be used now. So this protons, after getting outside, when it comes outside, it is reflected by using the turning medium, so the your lasing medium, no. Okay, so actually this is a laser beam formation. Okay, so working on this laser, and here I have considered the 1 minute. Here I have considered folded resonator axial flow CO2 laser. Now, please draw this diagram. Okay. तुम्ही पहिल्यांदा हे काढा बरं का, पुन्हा द्यावं. Please draw this diagram. All of you, please draw this diagram. लिखते. Okay, now please draw this diagram. This both. Give also name also that diagram. आपण फिजिक्स मध्ये फिजिक्स डिस्कस केल्यामुळे तुम्हाला एकदम डेप्थ मध्ये आल्यामुळे मे बी तुम्हाला थोडं कन्फ्युजन वाटेल. बट दिस इज फॉर यू. Okay, you should know that basic how to produce that laser. Okay, so for that purpose I have gone for. आणि पुढचं सोपं आहे की बाबा लेझर आता आपल्याला माहिती आहे की लेझर तयार झाले तर काय फक्त ते लेझर आपण काय करतो विथ द हेल्प ऑफ द लेन्स वी आर फोकसिंग ऑन द स्मॉल पोर्शन ऑफ द वर्कपीस ओके and by focusing continuously due to that heat energy whatever content in that laser no so that melting will happen start on that localized area only and so that through that melting and the vaporization material will be removed that is simple. आता इथं काय मी एक्झाम्पल घ्यायचं CO2 लेझर म्हणजे CO2 गॅस घेतला ना ट्यूब मध्ये म्हणजे तुमच्या लेझिंग मीडियम मध्ये ना लेझर ट्यूब मध्ये आणि त्याला मी काय करतो स्टिम्युलेट करतो ना विथ द हेल्प ऑफ दॅट इलेक्ट्रिकल एनर्जी okay from that cathode. We are going very in the detail. आपण दिले आपण काय करतोय लाईट देतोय नॉर्मल लाईट म्हणजे ऑर्डिनरी लाईटिंग म्हणू शकता त्याला आपण अँप्लिफाय करत जातोय सो वी आर गेटिंग दिस बाय अँप्लिफिकेशन ऑफ लाईट वी आर गेटिंग दॅट सिम्युलेटेड इमिशन ओके सो दॅट simulated emission is our laser okay so light amplification please remember light amplification by stimulated emission of the radiation. Okay. Ah, again, please remember this point. Whatever we are giving the energy, okay, so that energy maybe in the form of heat, maybe in the form of electricity, and maybe in the form of light. And that heat input or energy input is going to convert as output in the form of laser, and that that energy in the form of laser, no, that we can use for the machining operation. Okay, इतर लेझर तयार होते. ते आता लेझर कसं तयार झालं वगैरे आपण ते डिस्कस केलेलं. Okay, and that laser we have to follow on that our workpiece. Okay, small area. Okay, so remaining part we will discuss in the next lecture. Okay, that characteristics and other. Again, I'm going to take that types also, everything, that CO2, what, how that it will operate, and okay. But remember this diagram is important. This us 1 minute. Quickly, hello. Quickly, I will write your attendance. Please wait. From your name, I will write attendance. पुढचं एक थोडं शिकू द्या का सध्या थांबू. आता जरा थोडं हेवी झालं वाटतंय. हॅलो, कुणी तर सांगा. आपण फिजिक्स मध्ये फिजिक्स थोडं बघितल्यामुळे जरा जड वाटत असेल. Okay. Hello. 1 minute.